Hello there. Welcome to our channel, The Elegant Equation. How to learn physics using only 5 simple math equations. What you are about to watch is a brief clip of one of the various physics lessons as shown in this slide offered on this YouTube channel. If you feel you need more in-depth explanations about a particular topic, please join our online classroom for free on weekends. Our topic for today is about the laws of motion. This is lesson 10 in our series, Inscriptional Physics, The Elegant Equation. In our previous lesson, I demonstrated how to measure the height of a building, or the length of a string attached to a kite gliding in the air, without using a giant ruler or a sextant but by using SAO TOA. In this lesson, I will teach you how to measure the height of a building by simply dropping an egg. But before we do this, let us first understand the principles behind the most elegant equations of all time, Newton's famous laws of motion. Sir Isaac Newton, the greatest mind of all time, and the original formulator of all known equations, where even Einstein's formula E equals m times c squared, was actually derived from his work on force equals to mass times acceleration. As I will prove it in our next lesson on dimensional analysis, is best known for his theories on the laws of gravity and forces. His first law is known as the law of inertia. It tells us that an object at rest, or in motion, remains at rest, or in motion unless an outside force moves or stops the object. A good example of this law is the tablecloth trick. By quickly pulling the tablecloth towards the direction of the arrow, the base will remain at rest on the table, since no outside force disturbs the flower base. His second law, known as the law of acceleration, tells us that an object of mass will be in motion if an outside force moves the object. The tablecloth will be in motion when an outside force, probably represented by a person, pulls the cloth toward the direction of the arrow. The third law of motion, known as the law of forces, tells us that for every applied force, there is always an equal but opposite reaction force. In our example, the tablecloth will be in motion when an outside force pulls the cloth toward the direction of the arrow. However, the cloth is also pulling due to the force of friction of the table. Another type of motion is the free fall. The object is falling freely with no forces acting on it, no air resistance, except the pull of gravity. In other words, the object is simply only influenced by gravity, no more, no less. All objects free fall or accelerate due to gravity with a value of 9.8 meters per second square, which is approximately equal to 10 meters per second square. So, in this drawing, if the apple is 100 grams and the elephant is 1,000 kilograms, what time will each one hit the ground? In this next illustration, notice that when an object at rest is dropped from the top of the building, its distances of fall changes with time. Also, note that in 1 second, the object reaches a distance of 5 meters downward. In 2 seconds, the object reaches a distance of 20 meters. In 3 seconds, the object reaches a distance of 45 meters. In 5 seconds, the object reaches a distance of approximately 130 meters. This tells us that when the distance of the object is increasing, the speed of the ball is increasing as well. Furthermore, by knowing the time an object hits the ground, the height of the building can be determined. No other data are needed to compute the height. Try it. In our questions and answers portion, we are going to find the height of the building by simply dropping an egg from the top to the ground. In this problem, the guy is 6 feet tall. The weight of the egg is 65 grams. The wind velocity is 3 meters per second. What is the height of the building? Answers: the height of the building will be discussed and calculated in our next session. Thank you for watching. And don't forget to subscribe, share, and like. This is your Elegant Equation channel signing off.